kind of the balance of energy facilities. Prior talks have focused both on the basics as well as on wind turbines in particular. Even though my firm has quite a bit of experience in wind turbines, I will keep it light on that area and really focus more on the, as I said, the balance of the industry.
Can you just identify yourself?
Yes. Excellent. Thank you.
Good.
I'm Jim Barnes, one of the principals of the Centec. My colleague Eric Wood is here as well. We've both been serving the acoustics industry for well over 3 decades each. And we're the firm of Centec. Our world headquarters is in Cambridge, Massachusetts. We have a West Coast office in Los Angeles as well as one outside Philadelphia, Pennsylvania. We're a group of 50 professionals who are passionate about noise, vibration, and associated technologies. Next, please. We serve a whole variety of interested parties in these projects. They range from the developers, the owners, the equipment suppliers, the designers on the front end, but also community representatives, private individuals, many times on a pro bono basis for those individuals, as well as not, last but not least, state and local agencies. Next slide, please. This is the 4th one. Picture, this is of North America, showing our tremendous demand that we have for energy. Those are not just light bulbs. My understanding is they also include gas flares, which is also part of our energy usage. Next slide, please. Slide 5. Here talking both about the power generation side as well as the electric and gas transmission side, which I understand is covered by the board as well in applications. Next, please. Have numerous different type of power generation sources, typical fossil fuel, also nuclear plants, newer combined cycle plants that include gas turbines. Gas turbines you can think of as kind of a jet engine, industrial strength jet engine that also produces electric power directly, as well as it uses the waste heat to generate steam that is also used for other purposes such as generating electricity. Other items, certainly the wind turbine, solar projects that we have, hydroelectric. Worked on a hydroelectric project here in Vermont, too far away. It's an interesting one, but we don't have time to go into that one. Landfill gas, even though it wasn't in the States, there are different, I understand, methane capture systems that you do have that you're using for generating power. And then a few other ones, the integrated gasification plants, which really aren't, I don't see as a future here in Vermont. It requires quite a bit of land, and it's usually put near the sources of coal as well, and several other plants. Next slide, please. Slide 7. Just 3 sort of different bullets that talk about the type of analysis that we do, the sort of steps that we go through. One, we need to, either through measurements or through theory, come up with predictions on particular models to be able to understand what the sound emissions are. The previous speakers had talked about sound power. It's very important for us when we're doing our analysis to understand the source characteristics, which include overall A-weighted sound power as well as spectral content, what the frequency content is for those sources. We also use sort of the classic source path receiver model. And many of you that are outside of sound but may be involved in, say, air modeling would use the same type of concept where you need to understand the source. How does the sound get through the path out to the receiver, a residence, the actual person, and we're trying to really address in our overall analysis. And finally, the noise goals, and the requirements. Those are clearly necessary so that we can have some kind of understanding of whether or not mitigation is necessary. The next slide, please. In slide 8, I will talk in future slides too about some different type of mitigation techniques and examples, but they may apply to the source, or you may worry about the path itself, somewhere between where the source is making the noise and where it's being received, and finally at the receiver, at the resident's home. We can focus on that as well. Next slide, please. Considerable range of energy projects. I'd say we've worked on almost every type. I'd say there must be a few out there. If those few have a noise problem, we'll probably at some point hear about it. No pun intended. At the upper right-hand corner, you can see sort of a vertical jet shooting out. That's a high-pressure steam release. This actually came right at the end of construction for this particular power plant, where they're using high-pressure steam to help clean out the pipes and vent directly to atmosphere. And it's quite loud, quite broadband. It's a large aerodynamic jet that's occurring. And that same type of sound can also occur for typical power plants, which will have a boiler where you need to release steam in a emergency release or so to keep the boiler from, during an upset condition, from exploding. Much the same that you have probably in your basement on your water heater or your boiler unit. It's not going to quite shoot out like this, but you can imagine it's necessary. And to give you an example of what can be done about this, certainly for standard vents, we end up specifying different silencers. And there are numerous commercial silencers that can be put on to reduce the levels to acceptable ones. Just below that steam release, this one shows a cooling tower. Now it's out in the middle of Colorado, so there's not much around it. But I sort of pointed out that it's quite large, and in that its whole purpose is to remove waste heat from your power plant to allow for that power cycle to occur. Much like the purpose of your radiator in your car. You need to be able to have that heat be removed. And I'll show a little bit later on some examples of cooling towers that are located much closer to people. Below that, sort of the classic natural draft cooling tower that you see, those are what you'd expect for a nuclear power plant. And those actually do have some sounds, generally not noise, and they tend to be broadband in concept. Sometimes they do have muffler bank right at the bottom to be able to reduce the amount of sound, and other times not, because there's some falling water that will go through there and that sound will come out. Next slide, please. This is slide 10. Repowering projects. I'm not aware of any ongoing repowering project occurring in Vermont right at this point. But at some point where you do have older plants that have sort of reached the end of its useful life, there will be a need to repower it. And why we would repower it is because there's much infrastructure. There's already this investment. The land use hopefully is already compatible so that you can host a power plant in that location. You've got the electric grid that's tied into it, other transportation systems that can deliver fuel. In this particular case, it was an older coal-fired plant, and the types of sounds that you can have with a coal-fired plant can be the sound of the equipment inside, sort of the mechanical sound from pumps and motors that will come out through the shell, and that hopefully can be contained well by the shell structure. And then also there's quite a bit of air emissions control devices up here. So there may be some fans located up here, and you'll get both tonal as well as broadband sound from the fans, and as well as wrappers, where you, on the electrostatic precipitators, the purpose is, with the precipitators, as the gas flow comes through, the precipitators will pull out the particles, and then occasionally, just like your vacuum cleaner, you need to kind of kick off the dust, clean out the bag, or kick off the plates, and you'll end up getting a ringing sound. Many times that can be heard a long distance away. So that's something also is distinctive. Certainly you wouldn't have from any wind facilities or many other combustion turbine type facilities. And this is being repowered with the newer combustion turbine plant. Basically, jet engine connected to a generator. It takes the exhaust and puts it through a boiler, generates steam, and in that case, the steam is going back over to the existing power plant through the steam turbine generator. It's highly efficient. It's able to use the gas well. Next slide, please. Modeling side, this was done on also another project where they did some repowering. Took out an old boiler. It's just sort of a standard boiler that generated steam, went into a steam turbine, and instead they replaced it with a whole large steam turbine generator set powered by a combustion turbine. And in this case, as part of the overall permitting with the state agency, they also decided to put in, I have here, the air-cooled condenser unit. Something that you need to remove the waste heat from this process, particularly the newer process where it's generating a lot more waste heat. And in the past, they used to take that waste heat and dump it into a river reservoir, and they were concerned about the increase in the thermal load in the river. So the air-cooled condenser unit serves that purpose. Again, like the radiator in your automobile. Well, what you have in the radiator in your automobile, you also have a fan. And years ago, those fans were pretty crude and just stamped metal, and they could be pretty noisy. When the Chrysler K car came in the early 80s, they ended up putting in a much quieter fan design. Sort of borrowed technology from the navies around the world that had quieter torpedo and submarine blades, kind of skewed blade design. And so quieter fans certainly have come into play in the past 15, 20 years for a variety of power plant sources. Next one, please. Okay, this is slide number 12. It's a cogeneration project where we were asked by the Massachusetts DEP, our firm, to look at the overall project after it's been built and been in operation for several years. And yet there was an ongoing dispute between the owner and the neighbors. And both sides had hired their respective consultants, and the consultants went out and took a variety of measurements. And as Byam spoke about in the last talk, the ambient is not just 43, it's not just 45, it varies. Well, you can imagine if you have two different parties that measure over a period of time, it's not unusual if they're coming to two different answers as to what should be the ambient. Well, the state, at this point, really wished to come to grips, sort of put to bed with whether or not this plant was in compliance or not. So they asked our firm to go out and review the information that had been collected to date, take some additional new measurements, but we weren't going to go around the entire community here and take tons of measurements. We did not go and model this whole plant. We looked to see what had been done and then concentrate our efforts actually on developing a social survey. And so we came up with a survey, which hopefully did not bias the answer one way or the other, that would ask the neighbors in these areas around within a mile of the plant to sort of talk about their feelings. And again, feelings, noise is subjective, how they believed their overall environment was. Talk about the trains that would come through and aircraft noise, highway noise. And then, as I'm sure many of you have taken these kinds of surveys that kind of ask you the question, and okay, are there other things? And if they identified the power plant sound as as noticeable, we wanted to find a ranking in that. Really, how noticeable is it? And there were several different sources at this particular plant. One is an air-cooled condenser unit, basically just a lot of fans with a radiator, again, like your automobile car radiator. And many times at a plant of this size, that can account for half of the overall sound power level of that plant. So just this alone is going to produce as much sound as the balance of this plant. So it's worthwhile many times putting quite a bit of your energy and money into quieter fans, larger, well-designed fans that can operate at a lower tip speed. Other sources, the step-up transformers that are located outside the turbine hall. Much of the combustion turbines that are sitting inside the hall, hopefully contained well. And in this particular plant, there was another process where they're extracting carbon dioxide from the exhaust and cleaning it up, reusing it, bottling it, and selling it. This plant had sort of changed over time. Bottom line from our survey is that, yes, people could hear it at times. Occasionally it would be awakened. Could be when there was a steam release late at night. They had some changes at the plant, started up or shut down. But overall, it blended in with the neighborhood. It was a good acoustic neighbor. So that was the result that we provided to the state. Next one, please. Is number 13. Thank you. Sure, universities in the states and other large businesses, they have their own cogeneration plants. And in this case, there's combustion turbines that were located in this plant. Air inlet systems had filters and silencers located that would bring the combustion air into the combustion turbines. And then, again, the waste heat was going to be done with the cooling towers that are up on the roof. We looked at having reduced noise cooling tower cells, somewhat oversized, as well as putting barrier walls around that. And the purpose was to meet the city limits right along this area in front of the plants. And in this case, the nearest residences were dorm residents at a campus dorm that was literally right next door to the power plant. Next one, please. It's a project we worked on several years back. It's on a very large baseload power plant that was natural gas and oil fired, where the neighbors had experienced a tonal problem. That, well, not just one tone, but you ended up having a second harmonic of that tone too. It was around 150 hertz and around 300 hertz, and it could be heard out in the community. Tones and other distinctive sounds can be heard among a broadband background. And the utility in this case has to decided to go ahead and address that tonal condition. We helped them in two regards. One was looking at the source itself. There's an induced draft fan, where in these power plants you need to suck air into the boiler and then you need to suck air out. And in this case, the induced draft fan sucks the air out and comes out of this room across the horizontal duct into the exhaust stack and then upwards out to the community. So you can imagine right up here we've got a nice tonal source, several hundred feet in the air, that's got a nice line of sight out to a half a mile away to all the different neighbors. So we consulted for the project and helped them redesign the cutoff of this fan. As this fan spins around and comes upon this cutoff, you get a tone generated, much like chopping vegetables and so. And so instead of chopping the vegetables, we end up having the air being sheared by putting a V-notch cutoff in this point. So that helped reduce it, but we were still left with some remaining tone. And in that case, we specified a tune dissipative silencer. This is a silencer that has some special baffles within it that are tuned to the different frequencies of interest, the 150 hertz and the 300 hertz tones. And it was quite effective, and that one was also solved. Next one, please. Okay, nuclear plants. We do occasionally still get some some projects associated with nuclear plants. This one is up at Maine Yankee. It was necessary, once the plant was shut down, you still had the spent fuel that was sitting there generating heat and needed to be removed. So these are, again, removing heat, it's common. They're air cooler units and very high-speed fans. And there were many of them, and initially, when they were up at high speed, the neighbors that were maybe half a mile away could hear it. It was like an airplane that would just not take off. Fortunately, over time, the speeds of those fans diminish. This one is also what used to be, was going to be a nuclear power plant. It was in central Michigan. And they designed it, they constructed it, they put in all the steam turbines, they had all the electrical features in, they had a very large pool or reservoir for being able to remove that heat. But the economy and just everything in the nuclear industry went south. So instead, it sat there for a couple of years, and then several industrial partners came in and purchased the project and put in 12 combustion turbine generator units with heat recovery, heat recovery units as well. So they generated electricity. They also generated steam, which they put back over to the existing steam turbines that had never been used, and then also sent that steam across the river to an industrial project, a host that was over there as well. I'm pointing out also, this is sort of the first permanent noise monitoring, sound monitoring system that we had put in only for industrial use. They've been put in for airports and perhaps other sources, but I hadn't really seen those for other industrial uses. We had one here with a microphone up top, and then there was another one another couple thousand feet away from the neighborhood. And the reason for this system was twofold. The owner of this plant had made a commitment to the neighbors that they would only be above a certain level. It wasn't anything required by the state of Michigan, but still the owner, in agreement with the neighbors, said X amount, that's fine. So they wanted to demonstrate to themselves, and at times they did have levels that would exceed that limit. And so there was some intelligence in this unit. We were able to collect samples and look at some narrowband analyses and identify sources that are at the plant, as well as there are sources across the river at the industrial plant. There are a lot of fans over there, and you can clearly see the signature of those fans. And given that information, we worked with that industry across the river, and were able to resolve those noise problems out in the neighborhood. Next one, please. Standby diesel generators. I won't go into this much, other than think of it as a large truck engine that's, again, generating electricity. You can design a box that would incorporate both noise control and the exhaust path, these hoods, and be controlled. Mufflers up here, airlet, inlet. And these can be all kind of shapes and sizes. They're used for a variety of purposes. Some are for emergency use, some for standby use when the economics are such that you want to call peak shaving type application, where it's the utility wishes to cut back on electricity to you, and you kind of have to make up that difference. And there's some benefit from it. 18, please. Come around. Landfill gas power plants. The landfill over here will capture capture the gas. It's cleaned up a bit. There's some compressor units that need to be addressed in an enclosure. And then you have, much like the diesel generators, you have engine generator sets that are sitting in these enclosures that are designed to contain the noise. Next one, please. Wind turbines. So we see we've done it before. This is from a fairly large one that's in a very remote area, fairly remote. Not too many people that live nearby as well. Next one, please. won't go into this in any more detail. This is out in Indiana with a lot of coal, and the purpose would be convert the coal to gas first and then burn the gas, as opposed to trying to clean up the coal emissions after the burning process. Finally, next one, number 20. We're well over the country, over in California, where there's a hybrid power plant where they're having both a gas turbine generator set as well as using the solar power and focusing that on a fluid to be able to heat that fluid, create steam of that fluid, and also generate power as well. And next one, please, number 21. And I'm quite aware that the board also looks at issues associated with electric and gas transmission. Transmission lines here, which I understand they're only 345 kV in Vermont at this point. There may occasionally be some sound from those, audible, most likely during humid or wet conditions, kind of a crackling like bacon. We look at that, as well as on the gas transmission side, where you need to have periodically gas compression units that will boost up the pressure along that long line. And in that case, exhaust mufflers are needed for those engines, as well as containment and well-designed structures. And finally, transformers. This is also covered a bit in the previous talk. The transformers produce both broadband and sound primarily from the fans when they're operating. But the largest concern is with tonal sound. Sound is generated by alternating currents within the transformer, causing vibration internally within that transformer, and that's connected both through the oil and structurally out to the casing, and then the casing acts as a loudspeaker diaphragm out to the community. And the good news is that transformer design has come along quite a bit, much better metals. People are willing to put more copper into them, oversize them. They reduce the fluctuating fields, the alternating fields inside, so you don't get as strong a vibration initially. All that initially, it comes with money, but it turns out a higher efficiency transformer, it gives you less noise. Typically you can get 10 dB or more just coming along for the ride if you, as the owner, wish to go ahead and buy a higher efficiency transformer, because you get a payback by having a much more efficient piece of gear. We also, for those installations where you need additional noise control, there are barrier walls that are put around. This is also a partial enclosure, the open roof. And occasionally we've had ones where you've had to enclose the entire facility. And so like a 400 MVA transformer, we've retroactively put into an enclosure when it was necessary. There are also cases at substations where you have reactors, or maybe at some wind facilities too, where they'll be needed for additional electrical equipment. The reactor is called inductors. And finally, in number 23, our aim is to allow for and help with the production of useful energy, hopefully on a cost-effective basis, and be able to meet state, local project requirements, and to avoid adverse community reactions. We can achieve all of those, and I feel we've had a pretty good day. Thank you for your time and for your attention.
Just a second. Did you have a question?
I do have a point of clarification.
Yeah, sure.
You went
I'm sorry,
into
sir.
a lot.
Sorry.
Can you identify yourself, please?
Paul Bruhan. A point of clarification, sir, before you step down.
Sure.
You told us about all the mitigating methods that you had used on every project except one, and that was the wind turbine project, probably the one of most interest to us. Would you perhaps give us a little bit of information about what you might have done to mitigate there?
Well, I didn't want to be redundant with some of the previous speakers. However, I look at one, siting, certainly having whether it be setbacks or looking at what your existing background conditions are and overlaying what you would predict would be the sounds and see what those are. But I would also look at the turbines themselves. There's been, over the past 10, 15 years, obviously scaling up in overall size of these turbines. But also on the flip side, there's been an immense amount of engineering efforts on the equipment supplier's part to reduce the noise within the nacelle, the generator, the gearbox, and any cooling that's required. So I think the equipment suppliers certainly look at trying to reduce that. So mechanical noise that one maybe used to hear from the nacelles should be greatly diminished these days.
What about the modification of the actual blade design?
Well, there is one that we've witnessed, we've tested, looked at, that does use the serrated edges, and it's provided some useful benefit. Will it make it silent? No, certainly not. It's a large source. The tip speeds are quite high, even though it kind of looks from a distance, it's nice and lazy. Get up close, they're moving pretty fast. And there are many other. I mean, you can go to reduced noise operation, which different equipment vendors allow for different things. Some have some limitations as to how much they can slow the actual blade down, how much they can feather it. So I don't know if I've answered your question.
That's helpful. Yes, thank you.
Okay. Melody McLean. I don't know if this is a question for public consumption, but maybe I can catch you on the side. We live near a project, and we had a landscaper up this week to help us decide whether, if we did some plantings, if that would help with the noise levels. Is that something you ever do with wind power?
It's been used on a whole variety of projects, and I think much of it is because the difference between sound and noise is subjective, and you've got a whole range of people's reactions to identical sounds, identical situations. I think in the case of plantings, or maybe some other type of non-acoustic treatments, because the plantings themselves aren't going to do anything objectively to change the sound levels, unless you get tremendous amount. If you end up having a pretty good forest, then certainly that would be a benefit. But if it's just a row of trees, or if I had a potted plant in front of me, probably wouldn't know the difference. But out of sight is out of mind. In many cases, utilities in particular will use landscaping around their facilities, around substations, and that can go a long distance.
So that you can't see. That's what you meant by out of sight.
Yeah, I think,
But it'll take a few years to get to that point.
Jen, we're going to have a question and answer session for all of everybody at the end after we've heard all the presentations. So unless you have a clarifying question about something he said, we'll get into questions, and then all of the panelists can provide answers to these questions, like, for example, your landscaping one. So, right now, where we are, as I understand, the department has finished with the two people that they had decided that they had brought state to do presentations. Originally, we had planned to have them have 4 presentations, including one from Intrinsic Environmental Sciences as well as the Department of Health. But because those 2 presentations really focus on health impacts, and today's session wasn't about that, and we have a different session coming up that's going to be about health impacts, we decided not to have those today. So what we're going to do next is hear from Les Blomberg and Noreen Hession, except we're going to take a 5-minute break right now. And then we'll start back up again in about a quarter after.